right, guys, we are going to be talking about, we're in our Unit 2. We're going to turn to this function page right here. This is our second video on this. We're going to be talking about what is a function. And basically, a function is a relation, which we know a relation is a set of ordered pairs. But this is a special type of relation, and basically you have, it assigns one value or one y value, the range, to each x value or your domain. And what that means is, domain, not domains. Okay, and what that means is a function basically has no repeating x values. All right, and not a function is basically any relation. So this is basically any relation, whereas a function has to have no repeating x values. So a graph of a function would maybe look like a line. It can have lots of different areas. A line is probably one of the ones that we're going to look at, but we're going to look at lots of different ones. One thing that would not be a function would be something like this, and I'll tell you, because at this point you have repeating x values, meaning the x value is associated with this y up here and the x value is associated with that y value down there. Okay, and we're going to talk about that a little bit more. So in this situation, determine whether a given relation is a function, and what we're looking for is is there an x value associated with more than one y value? And we're going to kind of look at that like this. So here I'm going to look at my domain. My domain are my x values. Okay, so in this situation, I'm going to look and I'm going to say, okay, my domain is just the x values. So 5, 3, 2, 0, -1. All right, those are my domains. So my domain is the set of 5, 3, 2, 0, -1. Are any of these repeating? No. So yes, this would be a function. All right. What about this one here? My domain is just my x values. -2, 0, 2. Do you see where I'm getting this? 0, 2. I'm looking at the x values. We know that this is x and this is y. 3 and 2 again. All right. So look at here. I've got a 2 here and a 2 here. So these are the points that I'm worried about. This 2 is associated with the y value of -4. This 2 is associated with the y value of +4. So I have the domain of 2 associated with both -4 and +4. This is not going to be a function, because I have a repeating x value of 2. Okay, that's what you're looking for. Is the x value in this relation more than once? If the answer is yes, then it is not a function. So in this situation, my domain is -4, -3, -2, 1, and -3. Well, look, I've got -3 associated with -1, and I've got -3 associated with 2. I've got repeating x values, so this would not be a function. And what about number 4? My domain is going to be 1, 2, 1, 2, 3, 4, and 5. I'm not worried at all about what my y values are. Is there more? So I'm worried about just my x values. So since these are no repeating since the x values are all different numbers, then it will be a function. So I redid this one already. So if I'm looking at a table, you're doing the exact same thing. You're looking just at the x values. So here I've got 3 here and 3 here. This 3 is associated with a 5. This 3 is associated with a 3. Since I've got 2 3's and different y's, then no, this is not a function. All right? And then this one here, I'm looking at my x values. I don't see any x's that are the same. So yes, this one is a function. And this last one here, I'm looking -5, -3, 0, 1, 2, so no repeating x values. So yes, this one is a function as well. So go ahead and pause the video and see if you can do 8, 9, and 10 and check our answers. So pause it now. And hopefully you got these answers. This is not a function because I've got 4 in 2 places for the x values. This is a function because -8, -4, 0, 4, 8, these are all different numbers. Even though our y's are all the same, it still is a function because all I'm looking at are the x values. All right, and then 1, 2, 3, 4, 5. All right, moving on to these mapping. The way you figure out mapping, this mapping is basically showing that one ordered pair is going to be -3, 0. The next ordered pair is -1, 4. The next ordered pair is 2, 7. And the last ordered pair is 4, 4. So, do I have repeating x values? Well, my x values are -3, -1, 2, and 4. So this would be a function. It does not matter that this 4 repeats more than once. I don't worry about the y. I'm only looking at the x values. So check these. See if you can figure those out, and I'm going to give you the answer when I get back. So pause the video, work those problems. So here, this one is not a function because these would be -4, +4, -1, -1, but then -1, 7. So because this -1 is going with -1, -1, as well as -1, 7, our x value would be repeating. So that's what it would look like in a mapping situation. These are mappings. And our last one is a function because there's no repeating x values. Moving on. So that is how you determine if you have a function with either ordered pairs, with a table, or with mapping. But how do you determine if you have a function with graphs? Well, you use this thing called the vertical line test. And the vertical line test is basically a vertical line, looks like this. This is a vertical line. It's up and down. So if I was going to take an imaginary vertical line and move it from left to right, it must only touch the line of the graph once at a time. So if I was given a vertical line, this is an example of a vertical line right here, up and down. That's important, vertical, because it's a vertical line test. We're taking an up and down line. If I was going to use a pen or a pencil and just put that as a vertical line and just slide it from left to right, does this graph right here, does that blue line ever touch this vertical line more than once? And the answer to that is no. So this would be a function as long as it only touches it once. In this example, you'll notice as I move my vertical line left to right, it touches multiple times. It touches twice here. 1, 2, touches it twice here, and here, and here. It only has to touch it twice once, but that touches it multiple times. So for an example, in these examples here, you've got a point here and a point here. These are on the same vertical line, and as you can see, the grid actually provides you with vertical lines that you can actually use. So this point is at -3, 1. This point is at -3, -4. Both of these have an x value of -3. They're on the same vertical line, so this is not a function. Whereas these points, you can see, are on different vertical lines. All right, so yes, this is a function. Now here I've highlighted the graph, the continuous graph. These are discrete graphs, right? We talked about that before, discrete points. This is a discrete graph. Now I've got a continuous graph. This continuous graph, if I were to take my vertical line and run it across, it would only touch it one time. Or you can, again, you can use the vertical lines in the grid. This one here, if I take my vertical line, it's going to touch it multiple times. It's touching it at the top of the parabola, and it's also touching it at the bottom of the parabola. So no, this is not a function. So see if you can stop the video and work those problems. All right, so this one is no, this would not be a function because, as you can see, it touches twice on multiple situations. You can here and here, anywhere, those vertical lines. This would, yes, this would be a function because, as you can see, it never touches one of these vertical lines more than once. All right, so yes, this is a function. This one, however, this is the vertical line, so it's touching the vertical line multiple times. It's touching it this whole time. It is the vertical line, so that is going to definitely be a huge no. No, no, no. All of these points have the exact same x value. And this, if you take that, even though it's nice and squiggly, it's only going to touch it one time as I go across. All right, so this would be yes. All right, so that's it for this. You've learned about the vertical line test, determining how to determine a function from a graph, right? Visually or from a graph. You just use the vertical line test. If it passes, then yes, it's a function. If it doesn't pass, then no, it's not a function. And you've learned how to determine functions from ordered pairs, tables, and mapping. And that is it for right now. Do your Delta homework, Delta math homework.